volatiles. I'm done. Okay, this is, I think, a better schematic diagram here. So we have a sample here, you put it in a conical flask, and then it will be sucked. This is the first stage just now, the second. First or second? The sample introduction system. Okay? It will be sucked and then mixed there, and then will be burned. This is this pink or red color. Reddish color is flame actually. Okay? And then this is the light source, it will be shown through and it will be detected by the detector. The process is similar to UV visible, very similar, okay? Except for this one. Okay, and normally students will get confused and they put this in the UV visible also, or sometimes they totally forgot about this. But if you are asked to draw this diagram, please do not copy and paste this diagram and copy and paste it in the answer sheet. Okay, please draw it by yourself. Either you draw using your pen and then snap a picture, it's okay. But don't copy and paste this one. Okay? I need someone, this is the same thing, the one that I've mentioned just now. Okay? This is just the explanation of what I've just explained just now. And this is what's happening inside the flame. Okay? Imagine this is the opening. This is the opening, very small opening. And then there will be flame or fire coming out. All the sample, the filled sample, the mixed sample, the nebulized sample with oxidant and also with the fuel will be inside this area, these two areas. Okay, not on the outside. This side and also this point. Okay, and it will be measured here. Okay, and these are the areas that I mentioned just now. Please read about this. I don't want to mention it here. I want to see whether my technique here worked or not. If I do not mention it here, I just mentioned you have to read it. And if I ask any question, I would like to see everybody can answer it. Okay, this is the other technique using furnace. Furnace, just like we want to produce the proximate, want to get the result for minerals, the same thing. Okay, for detector, we also use the photo multiplier tube, same as UV visible, using the same photo multiplier tube. Okay. Actually, that's it. Done. We have covered the AAS. Starting from the principle, please remember at least 3 of the principles, and then we look at the machine itself, the compartment, not to see how it works, but what are the components inside the AAS. Okay, this is quite a new modern AAS, very modern AAS. You can see the light source there. But the one that we have is not like this. The one that we have is similar to this one. Okay, this is an old machine. This is older than me. Okay. This is where I said a beaker. So sample will be sucked and then will be burned here. This is the flame. Nampak api kan? We can see the fire here. And then normally this is the light source. You can see the handle where we can lift it up. We can lift it up. And the detector is here. And the read device is there. Okay. Super kan? And also, this is being opened. the lid is being opened so we can see the flame. But normally when we do analysis, we shut it. Kita tutup dia. Okay, so we can't see it. This is the one similar to what we have. Okay, similar to what we have. All this light, it's like a revolver. Okay, a magnum, not magnum, a Glock, a revolver, pistol, snap pistol kan peluru dia. Bila kita petik picu dia akan bergerak kan, peluru dia bergerak. Ni sama lah, dia boleh bergerak. Okay. If we want to use this lamp, so it will be up here. If we want this one, we press on one of the keys and then it will move up to there. Okay. Ini tempat yang saya kata tadi tu, all the mixture process occurs there, the sample introduction system. And this is the type of instrument we have. Similar to UVVs, we have single beam and double beam. Okay, single beam and double beam. But normally we use only the single beam in UV display in AAS. Okay. Okay, but normally I never ever ask about the schematic diagram of this one, single or double beam. Okay? But we do have to discuss about this problem. So we have some problem regarding usage of AAS. The first one is what we call as interference, gangguan. Okay? Where does this interference come from? Most of the time they come from the chemical compounds. Okay, maybe we want to detect carbon, but carbon 16 for example, but carbon 16 and carbon 18 they are very very similar and they love to stick with each other, and that's a problem. Okay, because we want only one, but there's two. But what about physical? Sometimes we use low quality water, and then that water cannot actually dissolve all the sample inside it, and then we have some physical problem. Okay? Ionization, we want everything to be ionized, but sometimes the sample that we want cannot be ionized or was not fully being ionized. So we do have some other things that are not in ionic form that will contribute to this interference. So what's the biggest problem in AAS is interference. And where does this interference come from? Either it's chemical, physical, or ion. Okay. Then, not just that three, we also have background scatter. This is also one of the problem. We did not extract the sample well, and then we have a lot of different elements with it that cannot be measured and will interfere with the results. The sample should have low amount of sodium, for example, but because of this background or scatter, we see a lot of sodium, but actually there's not much sodium inside the sample. Spectral interference normally occur when our light source is out of date, dah lama pakai. Okay, it should be replaced. This is spectral interference. So how can we cure it? These are the technique to cure it. Okay, baca. And one that can easily be remembered is this lanthanum chloride, the usage of lanthanum chloride inside the sample. Lanthanum chloride is being used to not purify, to make the pool water clearer. Kan orang letak dalam air kolam tu lanthanum chloride untuk bagi dia jernih. Or EDTA, this is a lot in food. Okay. Ini boleh baca, ni sama dengan yang saya cerita tadi. Okay. So what's the application? To detect metal, to detect any metal that we can found in food, okay, and put it on the label. How much sodium that this certain product have? We don't know. We need to analyze it. And this is the machine to analyze the amount or the presence of sodium, the presence of aluminum. So what is the application of AAS? To detect
metal atom.
yeah, these elements, this type of element. Okay, jadi yang pink ni, yang merah jambu ni, ini yang boleh di-detect lah. Nampak ya, belah sini tak boleh gas nadi, all this random element cannot be detected. Okay, and these are the advantages. The biggest problem with this machine is it can detect one element at one time. Some machine like ICP, it can detect 17 elements in one go. But for this machine, if you want to detect sodium, for example, sodium per one sample. If you want to detect another sodium in another sample, we have to do it again. We cannot detect sodium, aluminium, carbon using one sample or using one analysis, using one run. Okay, it's called a single element technique. So it's a tedious work. Again, problem with interference. Sometimes the result shows a lot of high amount of the element, but actually there's not a lot of it in there because of that interference. Okay, and also the preparation, we need to transform solid to gas, to liquid. We need to do the using furnace process. We need to make it into mineral first. Okay, yang bawah-bawah tu baca lah. And finally, limited to metal and metalloid. Just like we've seen in the slide before, some of it we cannot